Okay. It's quite interesting, this chapter. I will like some interaction. All of you already know this pretty well. So you have the horizontal and the vertical axes. Now we are entering the coordinate realm. In this world of coordinate geometry, what actually is there in GRE? I mean, in general, what coordinate is an entire world in itself where you are bridging the gap between geometry and algebra. So it's a world which exists in between. It's neither fully geometry nor fully algebra. So it's sort of a middle ground between those two. It's a bridge between those two. It tries to combine concepts of geometry and give them an algebraic language. That is what coordinate is all about. So in this chapter, we will learn how to address points, lines, axes, quadrants, circles, parabolas, though it's very rarely asked, but still we'll do that, and functions. Time permitting, we will also take up inequalities today. So these are the application bits of coordinate, and these are some fundamentals. Let's get started. Now, as you all know, in coordinate plane, there are two axes, the x and the y, which are perpendicular to each other. There is the meeting point, which is called the origin. The origin uh, is referred to as 0, comma 0. What is this 0, comma 0? So something, comma something is the way to express a point. Any point in this plane, in this xy world, is represented by x, comma y. Means the position on the x-axis and the position on the y-axis. For example, when you say your street address, I mean your home address, you will say first some street and some main, right? I mean the main and then some street. So similarly, uh, you have every point to be addressed as x, comma y. So when I say 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, -1, -2, -3, -4, -1, -2, -3, -4, So if I want to address this point, this will fall under the second main, second cross. So 2, comma 2. What about this point? So this is third main -1 cross. So 3 -1. Then this point -1 and 3. You should always write the x coordinate first. What about this? It lies exactly on the road itself. So it is 0, comma -3. Why 0? Because there is no x coordinate. It lies entirely on the y axis. What about this house? This house is -5, comma 0. Are you getting this? This is how any point in the coordinate world is expressed. The x coordinate first and then the y coordinate. Clear? Stop me if you have any doubt or if you feel the pace is going a little fast. I'm assuming that since most of you are from engineering background, are you all? Anyone who is from an arts background or who hasn't studied coordinate before? This is the chance to speak up. Or as they say, you'll have to hold your silence forever. Not forever, but yeah. Okay, fine. So which means most of you are already familiar with these basics. So you have the XY plane. Now let's talk about how to address the axes. This is the y-axis, this is the x-axis. This is the origin. The x-axis has a unique feature that every point lying on it has what? Has its y-coordinate to be 0, is it not? Every point you choose, any point you choose on the x-axis it will always have 0 as the y coordinate. Hence, we will write y equals 0 represents the equation of the axis. Y equals to 0 is the equation. It represents the defining feature. It's a defining feature of the x-axis. So every point on this satisfies the equation y equals to 0. Or conversely, anything which satisfies this equation will lie on the x-axis. Then what about the y-axis? Similarly, any point on the y-axis, every point on the y-axis will have 0 as the y coordinate, x coordinate. So we will say x equals to 0 defines the y-axis because that is the common shared feature through all points on it. Axes are nothing but lines, and lines, circles, parabolas, all of them are represented by equations in coordinate geometry. We are giving an algebraic form, an algebraic language to a geometrical figure. So when I say a triangle, a square, a circle, a parabola, a line, an inequality, all of these are figures of geometry, right? And what uniquely coordinate geometry does is it translates all of this into some kind of an equation. So like our computers, they use the data and they store it in some kind of pixels and 0 1 values, binaries. Similarly, coordinate takes all of these figures, assigns some equation to it to give an algebraic more digestible form. And why is this important, you may ask? Because especially for computers, they do not understand figures as much as they understand equations. And even amongst equations, it would be better if they are provided with numerical values. And even amongst numerical values, it would be better if they are binary. So this is the order of preference for each computer, for any computer, any machine. So figures are hard. So this is where coordinate kicks in and says, okay, don't worry, I'll translate the figures into equations which you will understand. So this is why even the axes are given an equation form to represent. So y equals 0 represents x-axis, x equals to 0 represents the y-axis. 0 comma 0 of course represents the origin. What about any line parallel to these? For example, what about this line? Or what about this line? Or what about this line? How would you represent them? They are also represented similarly. Now this blue line is parallel to the y-axis. So they will be written in the form x equals to something. Y-axis is written as x equals to 0. Anything parallel to it will be written as x equals to something. So whatever that point is. If it is plus 5, minus 5, minus 2, anything. And horizontal lines like these are parallel to the y-axis and x-axis. So they are written in the form y equals to 0. So these will be of the form y is equal to something. It can be positive if they are up. It can be negative if they are down. Got it? These are the ways to represent vertical and horizontal lines. Is this clear? Any doubts? Okay. The next point is there are two formulae for the distance and the midpoint. So given any 2 points, x1, y1, x2, y2, what is the distance between them? It's given by x2 minus x1 square plus y2 minus y1 squared. This is the shortest distance between any 2 points. For example, Please calculate the distance between 3 comma 4 and minus 5 comma minus 3. What will the distance be? So you will take the difference in the x coordinates, square it, and add it to the difference in the y coordinates. What is the difference in the x coordinates? 3 minus minus 5, 8. 4 minus minus 3, 7. Square them, add them, take a root. So 8 square is 64, 7 square is 49. So that is 113. Roughly about 10.5 something, I would say. So that would be the distance between those 2 points. So you can calculate the length of line segments also purely based on the location of the 2 points. What about the midpoint? So the midpoint is given by simply the average of the coordinates. x1 plus x2 by 2, y1 plus y2 by 2. For the same example, 3 plus minus 5 divided by 2 and 4 plus minus 3 divided by 2. It will be minus 2 by 2, which is minus 1, 1 by 2. So minus 1 comma half will be the exact midpoint between them. Write down this formula quickly. Written. Okay, I'm clearing the board now. Now, if you have any general line, any line like this, so there are three ways to represent or form the equation of a line. One is y is equal to mx plus c. This is called the slope intercept form. The other is called the 1-point form, and the other is called the intercept form. Note down these three quickly. I'll explain what each of these mean. Y equals to mx plus c, x by x naught plus y by y naught equals to 1, and y minus y1 equals m into x minus x1. So depending on what you're provided in the question, you can utilize that to form the equation. So what does it, what do each of these mean? So y is equal to mx plus c. This is called the general form of a line. Any line can be represented of this form. Here m represents the slope of the line. And what is the slope? The slope is related to the angle of inclination. And you may ask, what is this angle of inclination? So taking the positive side of the x-axis, when you curl your hands towards the line, whatever angle it makes, this angle, it's called the angle of inclination. And the slope is the measure of steepness of the line. How steep is the line? So if you want to give a numeric value to how steep some surface is, you will use the slope. For example, let's say you're trekking in the Himalayas, right? You are climbing the Mount Everest or you're summiting the K2. You would like to compare and you want to give a value to it. You have trekked both. So you will say, see, the Mount Everest is tall, but it is less steep. So you will say the slope is something like 2, let's say. whereas K2 is shorter, in a sense it is less in height than Everest, but it is steeper. You will say the slope is 5. It means it is more than 2 times as steep as the uh, Mount Everest. This is how you would like to give a number, right? To get a sense of the steepness. Similarly, every line will also have a steepness, and that is measured by the slope of it. What is the formula to find the slope? M is given by y2 minus y1 by x2 minus x1. That's it. Y2 minus y1 divided by x2 minus x1. Take the difference in the y coordinates, take the difference in the x coordinates. You will find the slope. What is this C we are talking about? This C refers to the point on the x-axis where it cuts the x-axis, I mean y-axis. It's the point on the y-axis where it crosses the line. So this point is called C. That has another name. It's called the y-intercept. We are representing that as y0. You can use either of the notations. So it represents the point on the y-axis where it cuts. Intercepts means it cuts. Where does the line cut the y-axis? That point is called C. So it can be 0, 5, in which case you will take C as 5. It can be 0, minus 6. Then it will take it as minus 6. It can be positive or negative, anything.
Sir, why you put this C as Y0?
No, this is just another way to denote C. You can say C as y-intercept. So we usually call intercepts with 0. X0 means x-intercept, y0 means y-intercept. It's a subscript. Similarly, the point where it touches the x-axis we call as the x-intercept. X-axis intercepts, where the line intercepts the x-axis, hence x-intercept. So x naught. Okay. Depending on what ingredient you're given in the question, you will have to choose a particular formula to write the equation of it. So for example, if you're given one point of this, let's call it x1, y1, we are given the slope of it. Let's call it m. Then you will use the 1 point form. So you will directly substitute the slope and you will use this y minus y1. Please remember this y and x are dummy variables here. They are not to be substituted with anything. They should remain like that as for forming an equation. These x and y's are dummy. Don't substitute anything in place of it. So for example, let's take the line passes through 4 comma minus 3, right? So the equation will become what? Y minus minus 3 is equal to m. Let's take the slope as 4. So 4 into x minus, what is the x coordinate? 4. So you simplify this, you will get the equation. So you'll get y plus 3 equals to 4x minus 16. Y is equal to 4x minus 19. This will be the equation of the line. Now, if you are given 2 points on the line, how do you then figure out the equation of it?
Sir, I have a doubt. I'm so sorry to interrupt you.
Please ask.
This Y minus Y1 is equals
Hmm.
to M in bracket X minus X1. So what
Yes.
exactly is Y and Y1 here?
So y1 is the coordinate of the single point that you are taking into consideration. So you know 1 point on the line, right? So that coordinate is x1, y1.
Okay.
Y1 will be that and x1 is that. Y and x here are dummy variables. So they just are used to represent the correlation between the y and the x coordinates of any general point on the line. So all equations of lines, points, circles are some sort of a relationship between the x and the y coordinate. Okay. So these x and y are just dummy variables here. They are not to be substituted, but what they actually mean is, if I take any general point P called x comma y, what is the relationship between them? Then it means if it lies on the line, it means it satisfies this equation. What is the equation? 4x minus 19. Y is equal to 4x minus 19. What does this mean? If I am claiming some point 6 comma minus 2 lies on the line, it should satisfy the equation. Means what? The x coordinate if you put in place of x and the y coordinate if you put in place of y, it must satisfy the given equation.
Mm.
So it will be minus 2, and on the right hand side you have 6 4 24, 24
4
minus
minus
9,
19.
5. Is it satisfying? No. Which means this point does not sit on the line. It does not lie on the line.
Okay.
Are you understanding? If let's
Yeah.
try 6 comma 5. Let's see if it satisfies. 6 fours are 24, 24 minus 19 is 5. Y is also 5, which means I have another point. 6 comma 5. The point 6 comma 5 does lie on the line. Why? Because it satisfied the equation. Conversely, if you know something sits on the line, it should satisfy the equation. Or if you have the equation of a line, any point which satisfies the equation, any pair of x and y which satisfies the equation will also be a point on the line. So this is the bridge we are talking about. We are moving from an equation, we are moving from algebra to some geometric intuition.
Okay.
So I was saying, if you are given, what about if you're given 2 points? So if you're given 2 points, let's call them x2, y2 and x1, y1. First, what will you do? First step is take the slope. How is it? Y2 minus y1 by x2 minus x1. Second step is use the 1 point form. Y minus y1 equals m into x minus x1. Got it? Now let's try out one question. Please open page number 192. Now for this chapter, we have to do it case wise, okay? Which means after each formula, we'll be discussing some questions. Open your books, please keep them handy. Question number 1. I would like someone to read the question. Page 192. Coordinate insertion. Okay, Abhishek S. Sir, please read the first question.
What is the equation of the line that passes through the points 4, 5 and 6, 9?
Hmm.
First, we have to find the slope.
Correct. What is x1, y1, x2, y2?
X2, 6, 9.
Hmm. How much is this?
Two.
2. What is the first step? What is the second step? Use this formula. So y minus, what is y1? What would you like to take as x1, y1?
So
5
y1 would
and
be
4.
5.
Y1 is 5. 4 comma.
X1 is 4.
Please simplify this. Open the brackets, simplify and tell me the form as y equals to something.
So it would be y is equals to 2x minus 3.
Perfect. 2x minus 3. That's it. That's the equation of the line. Everybody got it?
Yes, sir.
Great. The next point I want to raise is, what do you do when two lines are parallel or when two lines are perpendicular? So this is the axis. Then you have lines which are running like this and like this. So let's say they are perpendicular to each other. What do you do then? So then there's a relationship between the two lines. L1 if perpendicular to L2, the slope of the product of the slopes is -1. Or in other words, one slope will be equal to the negative reciprocal of the other. And if lines are running parallel, if lines run parallel like this, then let's call this L3 and L4. If L3 is parallel to L4, slope of L3 will be equal to slope of L4. If they are parallel, the slopes are equal. If the slopes are equal, they are parallel. And if they are the negative reciprocals, they are perpendicular. They're perpendicular, they are negative reciprocals. Got it? Write it down quickly. Okay, move on to the second question. Please solve it. 2 minutes.
Sir, I have question in previous question.
Yes, sir, please ask.
Like when we check the equation of line with the first points 4,
Hmm.
comma 5, could we have checked it with 6, comma 9?
Okay, we can have, yes, we could have done it with 6 comma 9 also, but the equation would remain the same. Let's try. Y minus 9 equals to x minus 6 into, what was the slope? 2. So 2x minus 12. So y is equal to 2x minus 3. It will still be the same.
So it's not necessary to check with like one particular one.
Correct. It need not be just one of the points. It can be with the other also. It will still be the same.
Thank you.
Yeah. Okay, guys, tell me what is the answer to the second? Okay, let me help you out in that case. A line L passes through 2 points, 3 comma 7, 8 comma 2. So there is a line which passes through them. You need to find the equation of a line which is perpendicular to this, but which passes through 3 comma 7 like this.
Sir, should I tell you the equations? I
Yeah,
got both the equations.
please do.
Sir, one I'm getting y is equals to minus x plus 10. And the second one I'm getting y is equals to x minus 6.
Please recheck. They may not be correct. Maybe some sort of an error in the formula.
Is it
Anyone
y
else?
plus 4,
Y equals to?
x plus 4,
Very right. Then?
y is equal to minus x?
Very good. Let me help you out. So it will be equation of a line which is perpendicular to this. So first of all, this line is called L1 and this is L. L1 is perpendicular to L, which means the slope of this one will be minus 1 by slope of M. First, let's calculate the slope of M. What will it be? 2 minus 7 divided by 8 minus 3. So the slope is minus 1. So you know the slope of 1, it will be minus 1 by minus 1, which will be 1. So you know the slope of this line now. What is it? 1. We have 1 point through which it passes. So we can use the 1 point form. What is the 1 point form? Y minus y1 equals m into x minus x1. Y minus 7 equals 1 into x minus 3. Remove the bracket, open. So x plus 4 will be the equation of this line. Y equals to x plus 4. Do you now understand where you went wrong, Nilima ma'am?
Sir, but why didn't you use this m is equals to minus 1 in this equation?
M equals to minus 1. No, because the slope of the standard reference line is -1, I agree. But you want to find a line which is perpendicular to it. So for a line perpendicular to it, the slope will be the negative reciprocal of the other slope, which means is line ka slope the negative reciprocal of that, which will be -1 by -1, which will be 1. We
Okay,
are not finding the equation of this line. We are finding the equation of this line.
I actually calculated for -1.
So you would have calculated the equation for this line. Got it. Next, an equation of a line which runs parallel to L and passes through the origin. Okay, any questions in this? I'll be erasing for want of space. So you have the line and you have a line which runs parallel to this and it passes through the origin. So this is the standard line and this is the other line which you required, which passes through 0, 0 because it passes through the origin. If they are parallel, what happens to their slope?
Both slope becomes equal.
Equal. So this slope was -1, which automatically becomes the slope of this line also. You have one slope, you have 1 point. Use the 1 point form. Y minus y1 into x minus x1 into m. So this will be y minus 0 will be -1 times x minus 0. So y equals to minus x. This is the equation. Is this clear? Okay. Let's now come to discussing about how to compare the slopes. Now we briefly touched upon this, that the slope of a line is dependent on the angle of inclination. So just remember, also there are two kinds of lines. They are called the ascending and descending lines. It's quite intuitive. Anything which rises up is called an ascending line. Up in the sense something which goes off into the ultimately in the first quadrant. This is called the first quadrant. I hope you all know that. First, second, third, and the fourth. In the first quadrant, you have positive, positive. In second quadrant, you have negative, positive. In the third, you have negative, negative. And in the fourth, you have positive, negative as the signs of the coordinates. Here, x is positive, y is positive, right? So it will be plus, plus. Here, x is negative, y is positive. So minus, plus. Here, both are negative. So minus, minus. And here, x is positive, y is negative. So it will be plus, minus. Now, anything which shoots off into the first quadrant is called an ascending line, ultimately. And anything which falls down into the fourth quadrant is called a descending line, like this. Anything which ultimately falls into the fourth quadrant, it keeps going into the fourth quadrant, is called the descending line. Now, please remember, descending lines are assigned negative. They are negative by nature, and ascending lines are positive by nature. Descending lines are negative, ascending lines are positive. It's like a North Pole, South Pole thing, electron, proton thing. Ascending lines are assigned positive, descending lines are assigned negative. Now, if you need to compare the slopes of lines, there are two cases. One, if you're comparing the lines which are similar in nature, which means if both of them are ascending like this, or both of them are descending. If both of them are descending, then how do you compare? There is one way. What is it? The angle of inclination is directly related to the slope of the line. Please remember, when you're comparing lines of the same nature, the ascending line, be it two ascending or two descending lines, then whichever has the greater angle will have a greater slope. That's it. So in this case, let's say the blue line has 50 degrees, whereas the red line has 40 degrees. So which will be bigger, red or blue line in terms of slope?
Blue.
The blue line. It has a greater angle, so it will have a greater slope. So m of blue is m of bigger than red, m of red. In this case, let's say this is 150 degrees and this is 170 degrees, which will have a bigger slope.
The red.
Red one. Bigger angle has a bigger slope. So m of red is bigger than m of blue. This is the case when you're comparing lines of the similar nature. But what if you have lines which are opposite? Means if you have one ascending and one descending, how do you compare their slopes? So in this case, it's quite simple. Just follow this. Whichever is the ascending line, give a positive sign to it. Whichever is the descending line, give a negative sign to it. Apply that same to the slope also. The slope of the red line will be some positive number. Slope of the brown line will be something negative. Which is greater? Obviously, the red line will have a greater slope sheerly because of its positive nature. And the falling line, the descending line has a negative slope for that reason. This is only when you're comparing two lines of dissimilar nature. One ascending, one descending. Whichever is ascending will always have the bigger slope.
So here we will not be considering the angles.
Just a minute. Tell me.
So here we will not be considering the angles.
Yes. So when it is comes to ascending or descending lines, you will not be comparing the angles because it gets very confusing. Now you may think, oh no, because the sleeping line has a greater angle, it may have a greater slope. No. This is by convention that when you're comparing an ascending and a descending line, you must go with whichever is the just by the nature of the slope, not by the angle.
But it just in case of if one is ascending and the other one is descending.
Only yes, only for that case, yes. Let's try question number 4. Please look at your books. Page number 192. Who's this calling? Please look at the question number 4. Tell me the answer.
Sir, L2.
L2. Why?
Yes. So because the angle is bigger. So
Correct.
it has a greater angle.
Why? Because those two lines are of the same nature. Both of them are
Yeah, both are descending.
descending. Very right.
So which is why I looked into the angle.
Correct. Do all of you agree? Should it be option B? Okay. Let's talk about how to write the x-intercept or y-intercepts of a line. So given the form y is equal to mx plus c, you know what is m, the slope, you know what is c, the y-intercept, called y naught. How do we find it? See, when given an equation like, let's say 3x minus plus 4y equals to 12, if you want to find the x and y intercepts, it's quite simple. What you do is, for finding the x-intercept, put y as 0 in the equation and check what happens to x. If you want to find the y-intercept, put x as 0 in the equation and check what happens. So when you put y as 0, what happens? 3x becomes 12, x becomes to 4. So x naught represents the x-intercept, which is 4. Means it passes through the point 4, comma 0. And the y-intercept, how do you find? Put x as 0. So when you put x as 0, it becomes 4y equals to 12. So y naught becomes 12 by 4, which is 3. So it passes through the point 0, comma 3. So even when you want to plot a line, this is how you will do it. Given any equation of a line, to plot it, first find their x and y intercepts. So it 4, comma 0 and 0, comma 3. And the line passes through these 2 points. Hence, this will be the rough plot of a line. Try it out for the other one. Let's say 7x minus 10y equals to 140. Please draw in your own books a rough line. Plot this. 7x minus 10y equals to 140. Done? So what will
Yes,
it
sir.
be?
Sir,
What is the x-intercept?
x
20,
is equals to
0.
20.
Correct. What is the y-intercept?
0 minus 14.
Minus 14. Yes.
14.
So the figure will look like something like this. Minus 14 is here, 20 is here. This is the line. Now, in a given equation like this, how do you find the y-intercept? It will be simple. What will you do? Put x as 0, you will get y equals to c. So this will be the y-intercept. How do you find the x-intercept? Put x as 0. So mx plus c becomes to 0. So x becomes minus c by m. This will be the x-intercept. Just remember, for x-intercept, put y as 0. For y-intercept, put x as 0. That's it. Question number 5 and 6, quickly. 3 minutes, go on. Question number 5 and 6. Okay, what is the answer? Fifth question. Anyone? Okay, let me then help you guys out. For the fifth one, the slope of the line L passes through A comma B is 3 by 2. The slope is given 3 by 2. Let's start with the general form of the equation. Y is equal to mx plus c. So y is 3 by 2x plus c. What is the first question? Quantity A is x-intercept. How do you find the x-intercept? For finding the x-intercept, put y as 0. What do you get? Minus c into 2 by 3.
So x is equals to minus 2 by 3c.
Yes, minus 2 by 3c. And what is y naught?
So why not I'm getting c?
C. You need to compare the value of this. Quantity A is minus 2 by 3c and quantity B is c. Which of them is bigger?
C.
No, because we generally tend to
Achha, we don't
assume
know whether c is negative or positive.
exactly spot on. So depending on the value sign of C, it will vary. If C is positive, B. If C is negative, then A. So again, you cannot determine. Next, if line L passes through the origin, now it also passes through the origin, which means 0, comma 0 satisfies the equation. So let's put that here. What do you get? 0 equals to 0 plus C, which means C becomes 0. So the line L now has M as 3 by 2 and C as 0. So what does the equation become? Y is equal to 3 by 2 x plus 0. Now, it passes through A comma B also, which means B, that also satisfies the equation. So B equals to 3 by 2 into A. Now, what is quantity A? It is A. Quantity B is B. But what is B? 3 by 2A. Which is bigger? Is A bigger or 3 by 2A bigger?
A.
A is bigger. Are you sure?
No, sir. 3 by 2a.
Sure.
3 by 2a is 1.5a.
What if A is a negative number?
That's also a point.
So actually, we always go by this assumption that A could be positive or C could be positive something. But since we actually don't know, these are points. A comma B is a point, so you can have a positive value, negative, 0, anything. Hence, we cannot again determine. Got it? Now, question number 6. The slope of a line is given as -1. Quantity A is the x-intercept and quantity B is the y-intercept. You see here, if the slope is given, we can again start with the slope-intercept form. -1 x plus c. What is x-intercept? How do you find the x-intercept? Put y as 0. What do you get x-intercept as?
C is equals to 1, sir.
C equals to... No. Please put y as 0. So you get x as minus c by -1, which is c itself. So this is c. What about y naught?
C, sir.
C. Put x as 0, you'll get c. So what do you think the answer is going to be? Both of them have come out to be c.
Equal.
equal. So both of them are equal to each other. It is the option C.
Sir, I have a doubt.
Yes, ma'am.
Sir, in the fifth question, I'm so sorry, sir, I'm asking you the previous one.
No
Uh,
worries.
Sir, the second one, the second part where you've calculated for A and B, I did not get through that.
Okay. They have said the line L, which is that line, the same line which passes through A comma B, which has a slope of 3 by 2, also now passes through 0 comma 0. Okay. Are you getting this?
Yes, sir, yes.
So M is 3 by 2. So we can begin with the slope, or you can take the 1 point form. You have a slope, you have a point. So y minus 0 is equal to x minus 0 into 3 by 2. So y will be 3 by 2x. Is this right?
Right.
Now, this equation is the equation of the line L. If I claim a comma b sits on this line, it should mean it should satisfy the equation, yes or no?
Yes, sir.
So which means the y coordinate of that point must be equal to 3 by 2 times the x coordinate of that point.
Right.
Now, quantity A is A, quantity B is B. Now, but what is B? It is 3 by 2 times
Okay.
A. Now, without knowing the sign of A, you cannot actually comment. If A is positive, then B is bigger. If A is negative, then A is bigger. Are you understanding?
Got it, got it.
Okay. Okay. Now, I think it's not right for me to not give you a break. We'll take a quick break, about 9 minutes, and then we'll come back at 10:50. Sorry, 10:49. Okay, let's resume. We shall now come to the discussion on inequalities. You may be wondering why are we discussing this since we already have finished this, but we'll be talking inequalities with respect to coordinate geometry. Can we represent inequalities in coordinate geometry? Yes. Let's, for example, now please follow this protocol very carefully. There is a question which says 3x minus 4y is less than 12. Find the find the region in the xy plane or the rectangular coordinate system which satisfies this inequality. Now, please remember, inequality will not be represented by a single line. It will be by an entire portion of the coordinate plane. Multiple points will satisfy it. First step is you will write it as a line. 3x minus 4y equals to 12. You'll write it like an equation of a line. Second step is you will find the x naught and y naught. Then you will plot the line. Then you will do a litmus test with 0, 0 or 1, 0. Fifth, you will mark the region of interest. It's not return on interest, it is investment, it is region of interest. So 0, 0, first of all, is the origin. Now, let's follow the steps one by one. Write it as an equality and then write it as a equation, which is x naught, y naught. 3x naught is 12, x naught is 4. Then minus 4 y naught is 12, y naught is minus 3. We wrote it as an equation of a line. We found out the x naught and y naught. First, plot them. So 4, 0 and minus 3, 0, minus 3. Join these 2 points, it forms a line. Now, like if you take any A4 sheet and you take a cutter, you draw a line and you cut along the line. It will divide the sheet into 2 parts. Is it not? Now, similarly, it has divided this entire plane into 2 parts. Let's say this is the cutter line. It has cut into 2 parts. What you must do next is take the litmus point. It can be either 0, 0, 1, 0, whatever you prefer. Put it into the inequality. Put it here. So put 0, 0. So it becomes 0 minus 0 is less than 12, which means 0 is less than 12. Check if this is true or not. Is this true? Is 0 less than 12? Yes. Which means what? The region, the half of the plane which contains that litmus point, which is 0, 0 in this case, will be the region of interest. What if it did not satisfy? Let's say it was 3x minus 4y greater than 12. When you use 0, 0, you got 0 is bigger than 12. Is this true? No, which means the other half of the region, it will be the other half of the region which does not contain the litmus point because it failed the test. Are you following? If it passes the test, the half plane which contains the litmus point will be the answer. If it fails the test, the other opposite half will be the answer. Write these steps down. Write it as an equation, a linear equation. So it is a line. Find the x naught, y naught, plot the line, use the litmus test and check if it is true, mark that region of interest. If it is false, mark the other region of interest. Did you guys write it down?
Yes, sir.
Great. I'm erasing now. We'll solve one question of the kind. Question number 9. Page 193. In the rectangular coordinate system, which of the following quadrants, if any, contains at least one point x comma y which satisfies the inequality as given? What is the inequality given? Please follow the steps. 2 minutes quickly.
Sir, the 0, 0 coordinate satisfies the equation. So the region
Okay.
of interest would be, so I've been getting, sir, xy values as 1.30 and y is 0 minus 1.
1.30.
And for y-intercept, I'm getting 0 minus 1.
Okay,
So
correct.
the region of interest would be uh, the one which contains 0, 0 coordinates.
Which contains it. Very good. So what will be your answer, final answer?
Indicate all such quadrants. So, sir, I'm getting first quadrant also, second, third.
What about the fourth?
So fourth का थोड़ा सा ही part आ रहा है.
Correct. But the question asked if it contains at least one point also, then you have to mark that.
Okay. Then all the four.
All the four. Correct. It will be all the four. So first thing is you have to write this as an equation. 4y minus 3x plus 4 equals to 0. Write down x naught and y naught. X naught is minus 4 by minus 3, which is 4 by 3, which is 1.33. And y naught is minus 4 by 4, which will be minus 1. And like she rightly said, plot the points, join the line, and then check with the litmus test, which is that with 0, comma 0, let's say. So 0, comma 0, if you put here, 0 minus 0 plus 4, which is 4. Is it bigger than 0? It is a true statement, which means it satisfies. So the region, half of the plane which contains the litmus point will be the answer. Now, what is the question? Which of the following quadrants, if any, contains at least one point? Of course, first quadrant it has. Second quadrant, every point satisfies. Third quadrant, some point. Fourth quadrant, a little region, but it still has infinite number of points even in that small region. So it does also satisfy. Got it? Next. The next concept is reflection. Reflection of a point. You see, in GRE, they usually may not be as explicit and say find the reflection of a point 4 comma 5 along some line. They will say very cunningly, they will say the x-axis represents the perpendicular bisector of a point AB where A is 4 comma 5. So what it means is actually the same, that perpendicular bisector is nothing but a mirror line, is nothing but a reflection. So let's first plot 4 comma 5. Let's say this is the point. If x-axis becomes the mirror, let's say you have placed a gigantic mirror on the ground, you know by laws of physics that the image of A will be equidistant from the mirror line. So that is how the concept of reflection emerges. So the point where the image will be formed will be equidistant from this, and it will be perpendicular. Hence the term perpendicular bisector. So if this is A, this will be B, let's say. This will be what? If this is 4 comma 5. When you're reflecting along the x-axis, remember, keep the x coordinate the same. So B will remain 4.
4 minus 5.
Yes, negate the y-axis. So remember, when you're taking for x-axis reflection, keep x the same and negate y. When you're doing for y-axis reflection, keep y the same and negate x. If you're doing it for the line y, x equals to y or y equals to x, swap x and y. And if you're doing it for the equation y is equal to minus x or x equals to minus y, swap and then negate. I will explain. So this is for the x-axis reflection. What about for the y-axis? Let's say you place the same point along, the mirror along the y-axis vertically. So in this case, this will be the image. Let's call it C. The level remains the same, which means the y coordinate has remained the same, whereas the position has shifted towards the left. So it becomes minus 4 comma 5. So you kept y the same, you negated the x coordinate. Let's choose a line which is oblique. For example, y is equal to minus x. This is the line. In this case, it's a little unique. What you will do is, you will just swap or interchange the x and y. So it becomes, the image point becomes 5 comma 4. The image becomes 5 comma 4. Just swap x and y. Even in equations, if you have some sort of an equation, if you interchange the positions of x and y, it will become the reflected line, reflected circle, reflected parabola, whatever. Just swap x and y. Now for the last line, which is the other oblique line, the sleeping line. This is the line y is equal to minus x, also called the 135-degree line. This is called the 45-degree line, or the line y equals to x. For this line, for this green line, how do you calculate the reflection? So it will be swap the point and put negative value for both. That is how you will do. So you will take 4 comma 5, swap it first, it becomes 5 comma 4, then put negative for both. Minus 5 minus 4. That becomes the image of the point along y is equal to minus x. So what they'll typically do is they will say the point AD is the perpendicular bisector of the line y equals to minus x. Don't get confused, it just means the same thing. That means y equals to minus x is the point of mirror of reflection. A is the point which gets reflected to form an image D. So AD is the image line. Y equals to minus x is the mirror line. Please write down quickly. Please solve question number 12 and 13. Question number 12 and 13 in the book. 2 minutes. Okay, what is the answer? One of you have said -8 -2. Trinita ma'am. 13th question. Y equals to 3x by 4 plus 1. No, that is in fact, the equation that they have given themselves. You must find the reflection of this line. Okay, I'll be discussing now. Question number 12. What have they said? In the rectangular coordinate system, for the line y equals to minus x is perpendicular. So this is that line, y equals to minus x. This line is the perpendicular bisector, means the mirror line of AB, where A is given as what? -2, 8, -2, 8. This is the point A. It is reflected to form the image B. So this is the mirror line. How do you find -2, 8 and reflected? We have to first swap, then negate. So 8, -2 and then negate. So this becomes -8, 2. Then this line is reflected along the x-axis because that is now the perpendicular bisector of the line BC. So it becomes, C becomes, to reflect along the x-axis, keep the x the same, negate the y. So the answer is C is -8, -2. Very right, Pranita ma'am. Good job. Next, 13th question. In the reflect, what is the reflection of the line 3x minus 4y equals to 4 along? 3x minus 4y equals to 4 along y equals to x. Now, like I said, if you want to reflect anything along x equals to y or y equals to x, what must you do? Swap x and y. That's it. Put x in place of y, put y in place of x. Bus. So the equation will be y equals to 4 by 3x plus 4 by 3. What is the answer? 3y plus 4x equals to 4. No. That is for y equals to minus x line. For the y equals to x line, you have to just only swap. There's no need to take a negative sign for x. Got it? Okay. Is this clear to all? Any questions? Abhishek squares and Neelima ma'am and Pranita ma'am, any questions?
Sir, I didn't get the previous one. I still didn't get the previous one.
Okay. So in the rectangular coordinate system, the line y equals to minus x. This is the line y equals to minus x.
Mm-hmm.
This is the perpendicular bisector, means what? It's the mirror line.
Right.
For what? For the line AB, means there is a line AB where this is A and this is B. This is the line AB. It is the perpendicular bisector. It means if A is the point which is minus 2 comma 8, it is reflected along this line, it forms B. What will be the point of B?
2 minus
Huh?
2 minus 8.
No, for the what have you written now? So for the mirror line being y equals to minus x, you have to swap and negate.
And negate. Okay.
So swap and negate. What does it become?
So it first becomes, I mean, ulta ho jayega, right? That's
Ulta,
the
yes.
meaning of. So 2, 8, and then again negative. Minus 2, minus 8.
No. Swap in a sense, swap the x and interchange
Okay,
the x
sorry.
and y.
Okay. So 8 minus 2, minus 8, 2.
That's it. Minus 8, 2. Now, next, what is the next sentence? X-axis is now the perpendicular bisector. Means that is now the mirror line of the point BC, of the line BC. So what will be the coordinates of C?
Again, swap and negate.
No. That is for only for y equals to minus x. For the mirror line being x-axis, we wrote this, right? For the x-axis, what must you do? You must keep x the same, negate y. For y-axis, keep y the same, negate x. For x equals to minus y, swap and negate. For y equals to x, you have to just swap. So for the x-axis reflection, what must I do?
X, keep x as it is and negate y.
So I'll keep
Minus
minus. That's it. So this is your answer.
Okay. Sir, can you also explain in the similar way? I mean, through figures.
For which
The
one?
next question, the 13th one.
3x minus 4y equals to 4 along the line x equals to y. So there is, okay, first let's plot 3x minus y equals to 4. 3x minus 4y equals to 4. What is x naught? 4 by 3. What is y naught? Minus 1. Is it not? So minus 1, 4 by 3. This is the line. This line is reflected along the line y equals to x. What is the line y equals to x? It is the 45-degree line. You need to reflect this orange line. Okay, let's change the color. Let's say the green line along the line y equals to x. So let's pick any random point on this. How do you, let's call this x comma y. What will happen if it is reflected along this mirror line? What do? You have to swap, is it not? For y equals to x ka reflection, what must I do? I must swap it. So it will become y comma x. Do you follow? Yes, no?
Yes, sir. Yes, sir.
Okay. So if I chose this point, when it is reflected, it will come here. Let's say I chose this point. It is merging, it is on the intersection between the line and the mirror line, so it will stay there. So if I join that, so this will be now my reflected line. How now there is one way to do it. One is the simple way where I just explained. So if you want to reflect anything along x equals to y, just interswap x and y. So wherever x is there, put y. Wherever y is there, put x, and this will become the equation. If you're not still convinced why this is so, let's try. Okay, so what is the intercept of this line? -1, this point. So when it gets reflected along the line y equals to x, what will it become? 0 comma -1 will become -1 comma 0. Yes or no? When you reflect along y equals to x.
Yes, sir.
So we have one point on which the reflected line lies. And let's take another point here. What is this point? 4 by 3 comma 0. When it gets reflected, it becomes 0 comma 4 by 3. You have to swap them. Yes. So we have 2 points. You can form the equation with this. How? First, you'll find the slope of it. I mean, you actually don't even need the slope. You can use directly the intercept form. So what is the intercept form? X by x naught plus y by y naught equals to 1. Put x, well, what is x naught in for this line, for the blue line? I'm saying -1.
-1 plus
What is y naught? 4 by 3. So let's simplify. It becomes minus x plus 3y equals to 4, or 3y minus 4x equals to 4. Is that what we got?
right.
Yes. Just remember, if any figure, if it has to be reflected along the line y equals to x, just swap it. I mean, swap what? Swap the coordinates. Wherever x is there, put y. Wherever y is there, put x. That's it.
Okay.
Coming to the last 3 concepts for today, which is about functions. We'll discuss circles and a little bit of parabola. What are functions? Now, I think all of you being math students already know what functions are. You have done calculus maybe, or even if you have not done calculus, you may have done some polynomial stuff. So a function is a machine which takes in some input, it spits out an output. How do we write it? Function bracket input is equal to output. Now this bracket does not mean multiplication, as is usually the case, but it's just a notation to write a function. So g of something, h of something, I of something, z of something, etc. All of these represent some functions which takes in an input value, it gives out an output. So for example, if I say g of 4 equals to 7, what it means is, if I put in 4 as the input, I get 7 as the output. It's like a computer. So if I put in 10 as the input and let's say it becomes -1, so then I represent it as g of 10 is -1. Simple. Whatever is within the bracket is the input. Whatever is outside the bracket after the equal to sign is the output. Solve question number 15. The function f is defined as f of x plus 3 equals to x square plus 4 for all non-zero values of x. Quantity A is f of -9. Quantity B is 148.
Sir, C, sir.
Very right. How? Good job.
Sir, I mean, I did it as x plus 3 is equals to minus 9, where I get a value of x equal to minus 12.
One
And
second, 1 second. So
that
f of x plus 3 is x square plus 4. You need to find f of minus 9. So the input is minus 9. Okay. So you got x as minus 12. Then
I substituted the value of minus 12 into this x square plus 4. And I got 148.
Perfect. So the output is 148, which is the same as quantity B.
Yeah.
Option C is the answer. Clear to all? Now, why are we discussing functions here? Because we can use coordinate geometry in order to simplify our life with functions. If, for example, you want to represent the behavior of some function, let's call g of x, what it means is the x-axis will be the input, y-axis is the output. Now, this is nothing new. All of you have done so many graphs before. You have done with electronics of V versus I, or maybe in data science, you may have seen some, bar charts, pie charts, all of that. It's nothing new. I'm just explaining from the base up. So the x-axis will represent the input, the y-axis is the output. So if you have some sort of a weird curve like this, then if I ask you what is the value of some function at g of 4, what is the value of this? How will you find? You will first pick where 4 is on the number line on x-axis, go up the graph, hit the graph, and come back to y. I repeat, climb up to the graph wherever it is, come back to y from it. So whatever this point is, let's say 5, then g of 4 will be 5. Next, let's say g of 5 you want to calculate, and this point is minus 3. So then you will climb down to the graph from 5, hit there, come back here. So it will be something less than minus 3, which means g of 5 will be, let's say, like minus 2.7. Then, if I ask you what is g of 0, how will you find? Start from 0, go up the graph, it hits here, and that is itself the point on the y-axis. So g of 0 is also 5. Then if I want you to find g of minus 2, right? Then you will say g of minus 2, you will come down to the graph, hit it here, come back here. So minus 3. This is the way to find the values of a function using a graphical method. Now, move on to question number 14. The figure above shows the graph of y equals to g of x. If f of x is defined as g of 2x minus 2g of minus x, then find the value of f of 2. Take 2 minutes, come on. Yes, any answers? Abhishek Square Source and Nilima Mama. What is it?
Sir, is it 4?
It is full. Very good. Okay, shall I solve one some more time? Okay, let me solve. F of x is given in through this equation. They have not given you the curve for f of x. The curve that they have given for is for g of x. What do you need to find is f of 2. So put, what is the input here? 2. So put x as 2 and check. 2 into 2 minus 2 into g of minus 2. So it becomes g of 4 minus 2g of minus 2. What does that mean? It means you have to find the value of g of 4 and the value of g of minus 2. Let's look at the graph if we can figure it out. From your graphs, just see where 4 is. Draw that grid and climb up to the graph. Hit the graph, come back to y-axis. What is this point from your graphs?
6.
6. And similarly from minus 2 you start, you hit the graph, you come back here. What is the point?
2.
So f will be g of 4, which is 6 minus 2 into g of minus 2. No, minus 2 is not 2. Minus 2 is 1. This is minus 1, minus 2 will
1.
go.
Yes, sir. It's 1. It's 1.
Yes. So it will be 6 minus 2 into 1 is 2. So this will be 4. So the value of f of 2 is simply 4. Option B. Is it clear? Okay. Just two simple concepts, guys. I know it's already time, almost time. Please hang on. Circle. Now we have discussed how to represent a point, a line, inequality, reflections, slopes, parallel lines, perpendicular lines, all of this. Let's now talk about how to represent circles. So any circle in coordinate geometry is represented. For writing any circle, you need two important features. What are they? You need where the center must be placed, and you need to calculate how much is the radius. That is what we would also do, right? In our school days, we would take the compass, we would fix our one end of the compass on a certain point, which is the center. We would measure the compass on a scale, the radius, and then you would draw the circle. So basically, we know by intuition also that you need these two things. You need the center, you need the radius. Let's call the center a comma b and radius as r. Then any general form of a circle is given by x minus a square plus y minus b square equals to r square. Note this down. X minus a square plus y minus b square equals to r square represents the general form of a circle with center a comma b and with radius equal to r. Please do not expand the brackets. It's not meant to be expanded. Okay, and these x and y, like I said, always are dummy variables. Don't substitute anything for them. Just write what is a and b given a center and substitute for r. So for example, if you want to create a circle with 2 comma minus 5 as the center and 10 as the radius, how will I write the equation? X minus 2 square plus y minus minus 5 becomes y plus 5 square equals to 10 square, which is 100. This is the way a circle will be represented. So it will be 2 comma minus 5 with a radius of 10. go on to question number 18 quickly. 2 minutes. In the rectangular xy plane, P of 0, 3 is the center of the circle, as shown in the figure above. Y equals to 2 is a tangent drawn. What is the equation of the circle?
Option C.
Option C. Very good. Why?
Like just putting the value of A and B.
What is A?
0,
0. B?
4,
4.
and
And
radius also
what is the radius? What is the radius?
Radius will be 2.
How?
Circle is offsetted, right? So it will be 4 minus 2.
Very right. So it's offsetted. So the circle center is 0, 4, and this point here is, what will this point be? 0, 2. How do we know? Because the y coordinate is 2. It lies on the y-axis, so the x-coordinate will automatically become 0. The radius is nothing but the distance from the center to the periphery. So this is the radius. So if this is 4 and this is 2, this distance will be 2 units, which is the radius. So we got the radius, we have the center. Put it into the equation. So x square plus y minus 4 square equals to 4. Hence it will be option C. Any questions, Abhishek S sir and Nilima ma'am?
No, sir.
No, sir.
Fine. One last thing before we wrap up. What is a parabola? Now you may have seen this shape very often in real life, but we may not have recognized it as one. So for example, you have seen the electrical poles and the cables or wires which hangs around. That is a parabola. You have seen dish TV, or maybe Lord Krishna's Tilak. All of these are parabolas. You have seen these dish TVs, or even um, you know steam water is running. I mean, there's water running, and if you want to heat it up, you use paraboloid mirrors, which are in this shape, and you'll see the sun reflected and getting concentrated and heating up the water here. So these are some common day occurrences of parabolas. Also, the trajectory of a gunshot or of an arrow will also be let's say you're standing here and you shoot, right? So it will go and it will fall like this. So this will also be a parabola, be it a gunshot. A gun would go even further, but the trajectory will remain the same. We shall discuss the parabola in the general form first. So y is equal to x minus h square plus k. This is the general form of the parabola, where the vertex is h comma k. What is vertex? Vertex means the point from which the parabola emits. That is called the vertex. And the mirror imaginary line which cuts the parabola into two equal parts is called the axis of symmetry. It's called the AOS, or the axis of symmetry. Now this parabola can touch the x-axis and y-axis at any point. So it can touch like this. So in this case, this is the vertex, this is the AOS, and these 2 points will be the intercepts, x01, x02, and this will be the y-intercept. And the procedure remains the same. To find the y-intercept, you will put x as 0 in the equation. If you want to find the x-intercept, you will put y as 0 in the equation. This is clear. How do we find, now the vertex also is clear. The vertex is h comma k. How do we find the equation of line for the axis of symmetry? It's pretty simple. See, this point is h comma k, right? And this is a vertical line. We know that all vertical lines are of the form x equals to something. But what is that something? It passes through h comma k, which means the x coordinate of this point is h. It means every point on this line will also have exactly the same x coordinate. So x equals to h represents the AOS. AOS is x equals to h. Please understand. A parabola is represented by the equation y equals to x minus h square plus k, where the vertex is h comma k. The axis of symmetry is represented by the vertical line x equals to h, and it may cut the x-axis at 1 point or 2 points or no points. Anyhow, if you put y equals to 0, you will get to know what the values of x will be. And if you put x as 0, you will get the value of y. And as you already know by now, because of the square term, it is going to represent a parabola. And it is also a form of a quadratic equation. If the square is on the x, it is a parabola, and it is a quadratic equation form. Excuse me. Written down?
Sir, for GRE scope only this parabola is used, or where the axis of symmetry could be along y-axis, that form also we have to take into account.
No. So inverted parabolas or oblique parabolas are not present in GRE syllabus. Not even this. So this is the root function. This is the inverted parabola. This is an oblique parabola. So all of this, because it will require some amount of trigonometry or at least some other basic calculus concepts, it is not there in GRE. Only the upward facing parabola. I mean, if it is downward facing, we'll have to just put a negative sign to it. There is nothing else about it. But no concept of the focus, no directrix, all of that, I mean, the parametric form, all of that is not there in GRE. Okay. Now, what are the different basic operations by which you can play around with the parabola? The basic operations are like these. First, you can move a parabola up, down, left, or right. Let's discuss how do we achieve this. Let's consider a very simple parabola. Y is equal to x square. It is the parabola which originates at the 0, 0, the vertex, which is the origin itself. And the axis of symmetry, okay, my back is low. The axis of symmetry is the y-axis itself. This is the simplest possible parabola. If you want to play around with this, if you want to move it up, what you must do is to the equation on right side on the RHS, you must add a constant. So y is equal to x square plus 7. If I do, it will pull the parabola up like this. If I want to shift it down, then to the equation, I must subtract a constant. So it will go down like this. If I say x square minus 10, it will move 10 units downward. Then if I want to move the parabola to the left, I must add a constant to the x, to x only. So y, if I want to move it to the left like this, then if I'm shifting by 4 units, let's say, then I have to add 4 units to x. So it becomes y is equal to x plus 4 squared. If I want to shift it to the right by 6 units, then what must I do? I must subtract from x that many units. So if you subtract 6 units, x minus 6 square is equal to y represents that form of a parabola. Are you understanding? These are the different 4 operations which must be done in order to move up, down, left, or right. Add something to the equation, subtract something, add to x, subtract from x. Note down, note down. We'll do 2 questions, then we can wrap up.